Okay, guys, so we are on section 9.1, Basic Principles of Hypothesis Testing. And this is a pretty straightforward section. Okay, guys. We've got a few definitions and then we've got a few examples. And then I will post those notes for you guys so you can get that done. And I'll try to get 9.2 out tomorrow. So, first we have a statistical hypothesis is often a statement about one or more population parameters. Then we've got a couple of definitions. The null hypothesis about a parameter states that the parameter is equal to a specific value. For example, h sub 0 mu equals 35. The null hypothesis is denoted by h sub 0, okay? The alternate hypothesis about a parameter states that the value of the parameter differs from the value specified by the null hypothesis, and that the alternate hypothesis is denoted h sub 1. So h sub 0 is the null. Lots of times we'll use a 0 or a 0 with a line through it to say null or not, okay? So the null hypothesis is an actual value. If we talk about the alternate hypothesis, it's going to say, well, it's lower than the null, it's greater than the null, or it could be either greater or lower. And that's where we get the left-tailed and the right-tailed and the two-tailed alternate hypothesis. If we have a left-tailed alternate hypothesis, this says that mu is less than 35. If we have a right-tailed alternate hypothesis, this says that mu is greater than 35. And if it's two-tailed, we just know that it's not equal to whatever they say mu is. So the two-tailed alternate hypothesis states that the parameter is not equal to the value specified by the null hypothesis. It doesn't say that it's greater than. It doesn't say it's less than. It just says that it does not equal it, okay? So in example 1, we have last year, the mean amount spent by customers at a certain restaurant was 35. Okay, guys, that means mu equals 35. The restaurant owner believes that the mean may be higher this year. State the appropriate null and alternate hypothesis, okay? So my null is actually going to be mu equals 35. All right, and then my alternate mu is going to be, this says higher. Okay, so it's going to be greater than 35, and that is my alternate hypothesis. 2, in a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. So mu equals 6.6 pounds. A doctor wants to know whether the mean weight of newborn girls differs from this. Notice we didn't say anything about higher or lower. It just says it differs. We want to state the appropriate null and alternate hypothesis. So my null is going to be mu equals 6.6. And my alternate is just going to be that mu does not equal 6.6. Okay. Finally, in example 3, we have a certain model of car can be ordered with either a large or small engine. The mean number of miles per gallon for cars with a small engine is 25.5. So mu equals 25.5. An automotive engineer thinks that the mean for cars with larger engine will be less than this. So less than this. State the appropriate null and alternate hypothesis. So the appropriate null is going to be 25.5, and then the appropriate alternate hypothesis should be mu is less than 25.5. Okay? Okay, so this brings us to the hypothesis test and the different types of errors that we can receive. So we begin a hypothesis test by assuming the null hypothesis to be true. If data provides strong evidence against the null hypothesis, we reject it and believe the alternate hypothesis. If there is sufficient evidence to reject the null hypothesis, we conclude that the alternate hypothesis is true. If there is not sufficient evidence to reject the null, we conclude that the null hypothesis might be true, but we never conclude that the null hypothesis is true. Guys, you're not actually going, the null is true. You're just going, we can't reject it. There's not enough evidence to reject. Okay? So, type 1 and type 2 errors in a trial. Type 1 and type 2 all come from whether you accept or reject the null and if it was actually true or not true. Okay? In a trial, the null hypothesis, and they give a little, in this explain it, they kind of give a little analogy, okay? So the null hypothesis is that the defendant is innocent, okay? So let's say that he's really innocent, but we say no, we reject that idea. That then is a type 1 error, okay? So he's found guilty. Type 2 error occurs if a guilty defendant is found not guilty, okay? So he's actually true and he's actually not innocent, but we didn't reject it. So you don't reject, but it was false. That's a type 2. So that kind of leads into, if you look it up in the book, they'll tell you that type 1 is the worst kind. And it goes back to, that's why they reference it to the innocent or guilty. If that hypothesis, that null hypothesis is true, but we reject it, that's a type 1 error, and we've now found an innocent man guilty. Okay? So, questions 4, 5, and 6, or examples 4, 5, and 6, just ask us to determine if these are type 1 or type 2 errors. So, 4 says a test is made of the null hypothesis mu equals 100 versus the alternate hypothesis mu does not equal 100. The true value of mu is 150, okay? And the null is rejected. Okay, so the null is rejected and the null is false, right? So I go up here to my chart. It says the null is rejected. Okay, so we reject the null. So we're going to be in this row right here. And what was the true value? 150. So that means the null was actually false, which that means this one. So we're looking at this column with this row. Who's the intersection? This is known as the correct decision. Okay, so it said the trial was, okay, the null is 100. We rejected the null. Turns out the null was actually 150, so that means the null was false. So we did the right thing, rejecting the null because the null was false, and that is a correct decision. Okay, number 5, and I'm going to go up here. And let's do this. Number 5 says a test is made of the null mu equals 18 versus the alternate says mu is greater than 18. The true value is 20 and the null is not rejected. Okay, the null is not rejected. We don't reject the null. Since we didn't reject it, that null was actually false because mu is 20. So who's my intersection? That is a type 2 error. Okay? So we get a type 2 error. Here's what we have, guys. Okay? And I'll try to do it without the chart also. Of course, you can always use your chart to answer your questions. A test is made, mu is 18, and the alternate says it's greater than. So it says the true value is 20. So that means that the null is false, okay? and we did not reject the null. Okay, so if you need to write those things down first, so I've got null is false. Okay, so it's got to come from here, but we did not reject the null. It's got to be one of these two, so it's type 2. There's my circle, there's my highlight. So let's try the last one. And the last one says a test is made of the null mu equals 3 versus its less than. That alternate says less than. The true value is 3. Okay, so that means the null of mu equals 3 is true. Okay, and the null is rejected. We made the wrong decision there. Okay, we convicted an innocent man there. So I go up here and we have the null is true. And then we have the null is rejected. That gives me a type 1 error. Whoops. And that sums up 9.1 over basic principles of hypothesis testing.